Hello, everyone. Welcome to our podcast, where we explore the cutting edge of AI research and business innovation. We have a truly special topic today, test time scaling with evolving meta thoughts, or MetaScale for short. 5 experts are here to break it down. Let's have them introduce themselves.
Happy to be here. I focus on strategic development for emerging tech businesses, always looking at how AI can revolutionize products and services.
Delighted to join. I'm a researcher specialized in the nitty-gritty of large language models and multi-armed bandit algorithms.
Great to be here as well. I study evolutionary algorithms and how they can refine LLM behavior in real time.
Hello, everyone. I'm deeply involved in advanced reasoning frameworks like chain of thought prompting and investigating how LLMs can optimize their own cognitive steps.
Hey everyone, I work on real-world deployment projects, scaling AI models in production for various industries, from finance to healthcare.
Fantastic. Let's dive right into MetaScale. Before we get into details, can someone give us a quick sense of what MetaScale is?
Sure. MetaScale is essentially a process where large language models actively choose the best reasoning strategy rather than relying on a single static approach. Think of it like having multiple thinking styles in a toolbox: logical deduction, reverse thinking, chain of thought, and deciding at test time which style leads to the best outcome.
Right, and the key point is test time scaling, so we're not retraining the model offline. Instead, we use a multi-armed bandit algorithm to pick from a set of meta-thoughts, then measure how well the model did with each strategy, and refine or evolve those strategies on the fly with ideas from genetic algorithms.
Precisely. Traditional chain of thought approaches boost reasoning for math or logical tasks, but they're not always flexible for, say, style control or open-ended tasks. MetaScale addresses this by adaptively discovering or evolving specialized approaches, like an AI that rechooses its game plan mid-match.
That's a vivid image, an AI that changes its game plan mid-match. I love it. Let's break this down a bit more technically. How does the multi-armed bandit piece actually work?
In a multi-armed bandit setup, each meta-thought, basically a distinct reasoning strategy, acts as an arm you can pull. After each sampling, you get a reward from a reward model that evaluates how good the generated response is. The bandit algorithm balances exploration of new strategies and exploitation of known high-performing ones. It's like rummaging through a big box of puzzle pieces, but using a systematic approach to find the best fit.
Exactly. And over multiple rounds, the bandit algorithm updates its estimates of each strategy's performance. Then we incorporate a genetic algorithm that takes the top-performing strategies, breeds new ones by combining key heuristics, and re-injects them into the meta-thought pool.
So it's continuously evolving. That's fascinating. This reminds me of the old Einstein quote, "Imagination is more important than knowledge." The model is basically reimagining new strategies on the fly, right?
I'd say so. Yes, it's looking beyond static knowledge of patterns. It's creating or mutating new problem-solving frameworks as it goes.
That's huge from a business perspective. Normally, you're buying or licensing a fixed AI model. With MetaScale, you're getting an AI that evolves during inference, offering better performance across tasks. It could be a big deal for any enterprise factoring in ROI on AI solutions.
Indeed, but let's not oversimplify. As a quick contrarian point, continuous adaptation might be beneficial, but there's a resource trade-off. Each iteration uses some computational budget, so organizations need to ask, do we have time to let the model attempt multiple meta-thoughts? There's a classic 80-20 rule at play. 80% of the benefit might come from a simpler approach if you don't have big latency constraints.
True, but for situations where accuracy or creativity matters more than immediate response speed, like in contract review, advanced simulations, or high-stakes decision support, MetaScale's iterative approach pays off. We have a client in the banking sector that uses evolving strategies to detect fraud patterns midstream, finding an additional 12% more suspicious cases.
That's a great real-world example. So how about the technical challenges? Are there any big pitfalls with dynamically generating new meta thoughts?
One big challenge is ensuring that these newly evolved strategies actually make sense. If you rely purely on random text-level crossover, you end up with nonsense. Instead, MetaScale uses the target LLM itself to propose how to merge or mutate strategies, which is more intelligent, but still not foolproof.
Precisely. You can think of it like designing a new blueprint. If your genetic algorithm is naive, like splicing paragraphs randomly, you get awkward, meaningless instructions. But if you prompt the LLM to logically merge approaches, it can produce a coherent new meta-thought that addresses specific weaknesses discovered so far. There's some overhead, but that's offset by the improvement in final results.
I see. And speaking of final results, I've heard this approach outperformed standard single-pass and even best-of-n sampling methods in certain benchmarks. Can we talk specifics?
Sure. In the experiments, MetaScale consistently outperformed baseline approaches like chain of thought alone or best-of-n sampling across tasks such as MMLU Pro, GSM-8K, and a challenge dataset called ArenaHard. One highlight was an 11% gain in win rate on ArenaHard with GPT-4 engines compared to plain single-pass solutions.
Yeah, that's pretty massive. Also, it scaled better when you increase the sampling budget. So with more attempts, normal best-of-n started hitting diminishing returns, but MetaScale actually kept discovering better strategies. It's like best-of-n is rummaging in the same old bag, while MetaScale keeps adding new and improved puzzle pieces to the bag.
That analogy is pretty vivid. Now, from a business standpoint, how might a large enterprise adopt this for real-world tasks?
Great question. Large enterprises often struggle with the variability of tasks. Everything from summarizing legal documents to analyzing financial forecasts to designing marketing campaigns. Traditional single-pass solutions can't always address that variety. With MetaScale, the system can pivot cognitively when the user's question changes domain or complexity. So you might adapt your AI strategy behind the scenes. A leading car manufacturer could use it for real-time supply chain management. Each constraint might demand a different reasoning pattern, and the system tunes itself midstream to find optimal shipping routes, pricing, or production schedules.
Another angle. Smaller or mid-sized businesses can benefit by plugging into a cloud-based MetaScale service, effectively renting this evolving inference capability. You don't need a massive data science team. And the final saved response, or meta-thought, can become a resource for future tasks, building an internal knowledge base. That organized knowledge base actually hints at a new frontier, where the meta-thought library is shared across an entire enterprise for domain-specific tasks. Over time, the library accumulates proven strategies for typical scenarios. Then you only evolve it when new, unusual tasks appear.
That's brilliant, and I have to channel skepticism here. Could it produce some weird or inconsistent results along the way as it tries to evolve?
Yes, definitely. During exploration phases, you might see outlier responses, especially if the reward model or the bandit's confidence intervals lead to a truly offbeat meta-thought. But that's part of exploration. Over time, the bandit punishes poor performance, so you converge on good strategies. Still, in a critical environment, you'd put guardrails on it, like a fallback to a standard reasoning style if the new approach fails certain checks.
I can confirm that. We had one instance at a retail client where MetaScale tried a meta-thought best suited for mathematical puzzles in the middle of a marketing pitch and ended up with a slightly robotic-sounding text. But after the next iteration, it recognized the mismatch and pivoted back to a more creative style once the system realized the marketing lingo-heavy approach scored higher in the reward model.
That's reassuring. A bit of trial and error, but the system learns quickly. I love how dynamic this is. Expert 4, you mentioned chain of thought earlier. How does that integrate with MetaScale?
Chain of thought is one potential meta-thought. So you might have a meta-thought that says, use a chain of thought, reason step by step, or maybe verify each step with self-reflection. MetaScale lumps these into a big pool along with other approaches, like summarization first or bullet point-driven reasoning. The bandit picks whichever approach might yield the best result for a given prompt. Over time, if chain of thought is consistently strong for math tasks, it'll get used more. But if we're dealing with creative writing tasks, a more free-flowing style might get favored.
Exactly. And from a strategic vantage, that's valuable because a single LLM instance becomes adept at a range of tasks. It's not stuck with chain of thought for everything, nor ignoring it altogether. It's the best of both worlds.
That's quite the synergy. Let me throw in a quick bit of humor. Expert 2, are you sure you didn't invent this meta-thought evolution strategy just to keep us all confused?
Well, I might have been secretly testing how adaptive your hosting strategies are, but in seriousness, it does introduce complexity, though it leads to real gains in performance and adaptability.
Fair enough. Let's switch gears slightly. For CTOs or tech leads listening, what would the implementation blueprint look like?
Start with an LLM that you can query multiple times. You need 1. A collection of initial meta-thought prompts. Some you craft manually, others you might retrieve from an instruction tuning dataset. 2. A multi-armed bandit policy, like upper confidence bound, that picks which meta-thought to deploy for each query. 3. A reward model to gauge the correctness or quality of each generated response. 4. Periodic evolution steps, where top meta-thoughts are combined by prompting the LLM itself to create new ones. Then you just run it for the desired number of iterations or until you hit your compute budget.
Precisely. And a huge part is designing a robust reward model. If your reward model is too narrow or inaccurate, you get suboptimal evolution. We see a lot of organizations rely on simplistic metrics like text length or single-step classification. You want a reward model able to handle nuance or even a suite of specialized reward models for different business objectives.
Right. And it's also essential to have careful logging and tracking of each iteration. You want to see which meta-thought was chosen, what reward it received, how it evolved, etc., so you can audit or debug if something goes off the rails.
That's a comprehensive blueprint. So from a cost-benefit standpoint, do we see this approach scaling for, say, a smaller startup?
Potentially. A small startup might appreciate that they can push certain queries through multiple evolutions if that query is crucial to their product, like generating marketing copy or advanced analytics. But they might also set a smaller compute budget for everyday tasks. The portability is there because you're not retraining from scratch. You're doing it on the inference side.
And some startups may even specialize in providing test time scaling as a service, letting smaller teams leverage it on demand. That's a future business model we might see soon.
This is so interesting. We've covered the essence of multi-armed bandits, genetic evolution, the synergy with chain of thought, and practical deployment considerations. Let's do a quick round of final insights. Expert 4, any last remark on the future of meta-thinking?
I think it's going to reshape how we view LLM intelligence. Instead of a single static intelligence level for each model, we'll talk about adaptive intelligence that changes with context and usage patterns.
Awesome. Expert 5, a final business case?
I believe we'll see more advanced use cases like real-time compliance checks in HPC environments, or dynamic data analysis pipelines that evolve their own steps. That's huge for heavy industries.
Expert 1, anything to add for executives tuning in?
Yes. Consider that the cost of a wrong AI decision can be high. An approach like MetaScale, which adapts and improves under the hood, can reduce error rates and amplify ROI, provided your reward model lines up with your real business KPIs.
Great. Expert 2, last words from the bandit side?
Don't be afraid of exploration. And remember, the variability you see is an investment in finding superior strategies.
Building on that, random mutations might seem scary, but guided evolution can yield surprising breakthroughs in performance. It's like discovering a new approach you never even taught the model.
Love it. That's all for today, folks. We tackled MetaScale and how it transforms test time reasoning into a dynamic, adaptive process. Thank you to all 5 experts for an in-depth, truly fascinating discussion. And to our audience, stay curious, keep exploring, and remember that sometimes the best approach might be the one your AI invents at the last second. Until next time. All right, everyone. Welcome back to Part 2. We promised a deeper look at the nuts and bolts of MetaScale implementation, plus some additional insights on business applications. So let's dive right in.
Indeed. Let's walk through a typical technical architecture. First, you have your base LLM. Then MetaScale layers on top at inference time. You load a set of initial meta-thought prompts. Some might be handcrafted, others extracted from an instruction tuning dataset. The multi-armed bandit sits in between the user query and the model. Each time you get a query, the bandit decides which meta-thought to attach to that query based on prior performance.
That's right. We can imagine each meta-thought as an encoded chunk of text that sets the cognitive mindset and problem-solving strategy for the LLM. The model is then triggered to respond accordingly. Next, a reward model evaluates that response, awarding it a score. The bandit algorithm updates its internal estimates, which gradually tilt selection probabilities in favor of better-performing meta-thoughts.
Meanwhile, every few iterations, depending on your set evolution interval, your genetic algorithm kicks in. It looks for the top-performing meta-thoughts, and then you literally prompt the LLM to combine or refine them. That might mean subtle changes like use bullet points to ensure clarity, or more radical shifts like adopt a persona with domain expertise in quantum computing. The new or child meta-thoughts join the pool, so now you have an expanded set of arms in the bandit.
Exactly. The elegance here is that you're not rewriting massive amounts of code, just letting the LLM propose new prompts. And from a scaling perspective, it's quite flexible. In a business scenario, you might decide to limit each query to, say, 3 or 4 iterations, if you can't risk too high a latency. But for critical queries, you can throw more compute at it, letting it spin across a dozen or more attempts.
This is getting me excited about the possibilities. Let's do a deeper technical dive on the multi-armed bandit portion. Expert 2, how are the confidence bounds typically calculated?
We often use an upper confidence bound, UCB approach. If a meta-thought M has an average reward mu of M based on prior uses, and it's been selected M times out of T total attempts, UCB will compute something like mu of M plus stussert log T and M. That B is a tuning parameter controlling exploration versus exploitation. After each response, we update mu-m and n-m, and the next time we ask the bandit to pick a strategy, it'll consider both the average reward and the uncertainty. Over time, the best performers rise to the top, while still allowing for some exploratory tries of underused meta-thoughts. And let's not forget the reward model. That can be a straightforward classifier, a regression model, or even a mixture of metrics, like correctness for math tasks combined with style scoring for creative tasks. If the reward model is incomplete or poorly aligned with your business objectives, you'll end up scaling the wrong strategies. So the reward model's design is half the battle.
Indeed. So on the flip side, let's do a deeper dive into the genetic algorithm side. Expert 3, as the evolutionary algorithm expert, what are we usually doing for crossover and mutation in textual meta-thoughts?
Absolutely. With typical genetic algorithms, you might treat your candidate solutions as strings of bits. Here, each meta-thought is effectively a textual representation of a role, mindset, or strategy. A naive approach might cut random slices of text from parent A and stick them onto parent B, but that can create ill-formed prompts. So we rely on the LLM itself to serve as a smart combiner. We prompt it. Here are 2 parent strategies that performed well. Please blend the key elements, but ensure internal consistency. It's like instructing the model to do the heavy lifting of rewriting. Mutation would be akin to, take this parent strategy and introduce a small twist, like adding step-by-step reflection or a different persona. Again, we let the LLM rewrite the text. Then we feed those newly minted strategies into the pool.
In a production sense, you'd set maximum iteration loops so you don't spawn infinite new prompts. Typically, we generate, say, 2 or 3 new children for each evolution cycle, which helps keep the search space manageable. If you're an enterprise user with unstoppable GPU resources, hey, go nuts. But most businesses have cost constraints. So you pick your intervals and the number of evolved strategies based on how many queries you'll process and how critical it is to have top-tier accuracy or creativity.
So if I run an e-commerce platform, how could I harness this in a live scenario?
One immediate application is product recommendation or dynamic pricing. Suppose your system is generating marketing copy, discount strategies, or personalized recommendations. MetaScale can attempt multiple reasoning styles for each user segment. The bandit part ensures the most profitable or engaging style is favored. Meanwhile, the system evolves new approaches. Maybe it learns a unique style that resonates with a particular demographic. Over time, the platform refines how it communicates deals, leading to improved conversion rates.
Another example is real-time chatbot support. Let's say you have an AI agent that fields complex customer inquiries about, for instance, technical product issues. You might want different reasoning patterns, a step-by-step troubleshooting approach, a direct short answer approach, or a friendly narrative with examples approach. The reward model could track conversation success metrics, user satisfaction predicted from chat logs. The bandit picks the best approach, and new approaches get invented if we find certain conversation threads frequently stumping the system.
In finance, we've integrated a MetaScale-like approach for portfolio risk analysis. Traditional systems might run a single forecasting approach. Here, you might have multiple meta-thought strategies instructing the LLM to weigh interest rates or global news differently. The system sees which approach yields more stable or accurate predictions over time, may be judged by backtesting or real returns. As market conditions evolve, the system can mutate strategies to emphasize macroeconomic data or pivot to more technical analysis. You get a self-updating AI analyst.
In manufacturing, we've worked on supply chain optimization tasks where each new iteration might be asked to consider not just production lead times, but also real-time freight costs, workforce availability, or environmental factors. With each round, the reward function can incorporate on-time delivery, cost savings, or carbon footprint reduction. Over the course of months, the MetaThought library shapes itself to respond better when disruptions happen, like shipping delays or raw material shortages.
Wow, that's powerful. Now, from a technology leader's perspective, we might wonder about concurrency, like how we handle multiple users or queries simultaneously. Do we need to separate the bandit state for each user?
That's a nuanced question. You can either maintain a global bandit state, learning which strategies are generally best across all tasks, or you can run distinct bandit instances for different user segments or business lines. For concurrency, you can store historical data in a shared database and update bandit statistics asynchronously. One approach is to batch updates, collect user requests for, say, 30 seconds, run an update cycle, and then have the bandit reevaluate. The best choice depends on how homogeneous your tasks are and whether you want cross-pollination of strategies. Also, you can track context embeddings, like tagging each conversation or query with domain labels. Then you effectively have a multi-context bandit. If it sees a query about manufacturing, it might favor manufacturing-tuned strategies. If it's about marketing copy, it might pivot to more creative or persuasive heuristics.
This is advanced stuff. Let's also talk about how one might measure success. Expert 1, you've mentioned ROI, but can we be more concrete?
Absolutely. For instance, you might measure success by reduced error rates on critical tasks. A quant trading desk might look at daily P&L changes, or a supply chain manager might track lead time reductions. In customer service, you might see an uptick in satisfaction survey scores or faster resolution times. The key is to define the reward model to reflect the metric you truly value. If you want to optimize for speed, incorporate response time as part of your reward. If you want brand consistency in marketing, add a brand alignment factor. Over weeks or months, you can examine which meta thoughts remain in frequent use, then measure how that usage correlates with your bottom line. That's how you tie the iterative approach to a tangible ROI or KPI.
Exactly. And I'd also argue there's a big intangible benefit. knowledge discovery. Sometimes the system evolves a meta-thought that ends up revealing new insights. Maybe for a financial model, it spawns a double check with recent commodity prices approach. That approach then triggers the business to reevaluate how they weigh commodity data. So you get real organizational learning out of it, which is a huge differentiator.
That's a fascinating point. I love the idea of an AI basically teaching the organization new strategies. Let me circle back to a big question: security and ethical concerns. Expert 3, do we worry that meta-thought evolution could produce unethical or biased solutions?
That's a valid concern. You do have to be careful with reward model design. If the reward strongly favors pushing certain product lines, the AI might learn manipulative or ethically questionable tactics. You mitigate that by building in alignment checks, filter out or penalize responses that violate policy or ethical guidelines. For bias, you can integrate debiasing or fairness constraints into your reward function so that any meta-thought showing disproportionate negative impact is suppressed.
And even from a brand reputation angle, you don't want a newly evolved strategy that's too pushy or that inadvertently crosses legal lines. So from a production standpoint, yes, you keep humans in the loop, or at least keep the system behind a review layer in high-stakes deployments. Over time, if everything looks safe, you can reduce that friction.
This definitely underscores that while the approach is flexible, it also calls for robust oversight, especially in regulated industries like finance or healthcare. So we're nearing the end of part 2. I want to close with a forward-looking view. Where do you see MetaScale or similar test-time scaling frameworks heading in the next few years?
I see them becoming more specialized in domain-specific cognitive strategies. For instance, a biotech version of MetaScale might keep evolving new ways to reason about protein folding or new drug compounds. The reward model might be heavily domain-tuned to measure the viability of those creative leaps. I expect more domain plugins with specialized knowledge bases and domain constraints baked into the evolution process. Adding to that, I'd bet on a wave of meta-thought orchestration frameworks hitting open source. People will build robust toolkits that let you orchestrate thousands of meta-thoughts, track them over time, visualize which ones get used, and so on. It's going to be an entire ecosystem akin to how we have MLOps platforms for training models, but now for real-time cognitive strategy evolution.
And from a research angle, I see synergy with reinforcement learning. Actually, bridging bandits and RL might yield systems that not only adapt meta-knowledge, but also learn from sequential tasks very efficiently, like building a chain of queries or sub-questions that systematically solve complex user requests.
From the business front, I expect enormous interest in adaptive AI. Enterprises are tired of static deployment. They want solutions that can keep up with new regulations, new consumer trends, or new data. MetaScale is a prime example of how to get ongoing improvements without extensive retraining.
Yeah, and we'll probably see more industry-specific reward models that come pre-packaged for, say, legal reasoning or shipping logistics. So a company can buy modular meta-thought expansions from a marketplace, if you will. It's going to be an interesting future.
Thanks, everyone. This conversation has gone deep into the mechanics, business angles, and future directions of MetaScale. I appreciate the thoroughness. Listeners, we hope you found part 2 enlightening as we unraveled the advanced inner workings and real-world deployments. Stay tuned for more episodes where we explore how AI can and will reshape industries and societies. Until next time, folks.